So next important topic is the vector addition by the rectangular components. So in order to start the vector addition by rectangular components, first we shall define what are the rectangular components of a vector. In our previous video, we have already defined what are the rectangular components of the vector. These are the mutually perpendicular components of a vector. Such mutually perpendicular components are called rectangular components of the vector. Now we'll see its explanation. Let A and B be the two vectors which are represented by two directed lines OM and OM respectively. The vector B is added to A by head-to-tail rule of vector addition. Thus, R is equal to A plus B in the direction and magnitude by the vector OP. This is the vector A with blue color. This is vector B with green color, and the resultant R is given by red line. According to head-to-tail rule, R is equal to A plus B. In the figure 2.9, AX, BX and RX are the x components of the vectors A, B and R, and their magnitudes are given by the lines OQ, MS and OR respectively. Thus, OR is equal to OQ plus QR. AX, BX and RX are the x components. This is the AX in the figure. BX is this x component of the vector B. Similarly, Rx resultant of x component is equal to AX plus BX, which means that the sum of the two magnitudes of the x components of the vector which are to be added is equal to the x component of the resultant. Similarly, the magnitude of y components of the two vectors is also equal to the magnitude of the y component of the resultant R. So this is the y component of the vector B, and this is y component of the vector A, and the resultant is given in this direction ry. So ry is equal to ay plus by. So how to get the magnitude of these rectangular components? Rx and ry are the resultants of the vector R. Thus R is equal to Rxi plus Ryj. Submitting the values of Rx and Ry, which are Ax plus Bx, Ay plus By. Thus the magnitude of the resultant vector R is given as Ax square plus Bx square plus Ay plus By whole square. Thus the magnitude of any resultant vector R can be determined by using this formula, and the direction is given as tan theta is equal to ry over rx. Thus tan inverse is equal to ay plus by over ax plus bx. Similarly, for any number of coplanar vectors a, b and c, if we have a large number of vectors like more than 3 or 4, we can write ax plus bx plus cx and so on other x components. Similarly, ay plus by plus cy and other components. And similarly, the direction theta is equal to tan inverse ay plus by plus cy divided by the x components. Now the vector addition of these rectangular components. How to calculate or find the vector addition of these rectangular components? This consists of following steps. First of all, find x and y components of all the given vectors. Find x component Rx of resultant vector by adding x components of the all vectors. Find y component of the resultant vector. Then find the direction of the vector. Theta is the angle which the resultant vector makes with positive x-axis. The signs of Rx and Ry determine the quadrant in which the resultant vector lies. For this, proceed as given below. Irrespective of sign of Rx and Ry determine the value of tan theta tan inverse Ri over Rx, which is actually equal to phi. from calculator or by considering trigonometric tables. Knowing the value of phi angle theta is determined. If both Rx and Ry are positive, the resultant lies in the first quadrant and theta is equal to phi. This is the first quadrant. If Rx and Ry both are positive, the resultant lies in the first quadrant and theta is equal to phi. If Rx is negative but Ry is positive, the resultant lies in the second quadrant and its direction is given by 180 minus phi. This is the second quadrant if Rx is negative and Ry is positive. If the vector lies in this quadrant, then its direction can be determined by using finding the theta then subtract it from 180 degree. If both Rx and Ry are negative, the resultant lies in the third quadrant. This is the third quadrant and direction is given by 180 degree plus phi. If Rx is positive and Ry is negative, its resultant lies in the fourth quadrant and its direction is given by theta is equal to 360 minus phi. So it is an example given as example number 2.2. Two forces of magnitude 10 Newton and 20 Newton act on a body in a direction making an angle 30 degree and 60 degree with the x-axis. Find the resultant force. Following the above steps, we first will write the x components of the force, which is actually equal to F1x. First components, x component F1 cos theta. F1 we know 10 Newton and angle we know cos 30 0.866. It comes out to be 8.66 Newton. X component of the second force F2x is equal to F2 cos theta. It is actually equal to 10 Newton. Similarly, y component. The y component of the first force F1 sin theta 1 is actually gives 5 Newton. The y component of the second force F2y is equal to F2 sin theta. This gives the F2y force. The magnitude of the x components or Fx of the resultant force is given as simply the summation of F1x vector and F2x vector, which is actually 18.66 in this case. Step 3 is the magnitude of y components of the Fy, adding the both values of y components of the force 22.32. Step 4 is the magnitude of the resultant force. We will scale these two magnitudes and we will get a resultant force of 29 Newton. Similarly, if the resultant force F makes an angle theta with the x-axis, then theta is equal to tan inverse Fy over Fx. Tan inverse Fy over Fx, tan inverse 1.196 equal to 50 degree. This is the direction of this vector resultant force and this is the magnitude of 29 Newton.